The P-51 Mustang. More than just an aircraft, it's a legend etched into the annals of aviation history.
Known for its exceptional design and profound impact on air combat, it pushed the boundaries of what was thought possible.
From its innovative laminar flow wing to its game-changing Merlin engine, the Mustang was a marvel of engineering.
But what made it truly revolutionary? Let's delve into the mechanics and design principles that defined its unparalleled success.
Join us as we uncover the genius behind the P-51 Mustang, one component at a time.
We begin by analyzing the main structure. The fuselage, represented here as a simple cylinder, can be segmented for detailed study.
In this minimalist representation, the essential elements of the P-51 are highlighted. The forward fuselage, the P-51 Mustang, depicted here using core geometric principles. We can detach the central fuselage section for closer inspection. We begin by examining the fuselage section, remaining static on the left. As the conceptual model rotates, as we examine the structure, the tail section smoothly detaches from the main fuselage. The P-51 Mustang consists of three primary sections. The fuselage forms the core structure. The fuselage, wings, and tail converge to form the iconic P-51 Mustang. Air superiority was critical during the conflict. The airflow over the top of the wing accelerates and spreads out, while the air underneath slows down. We see the primary forces acting on the wing. Lift, indicated in red, counteracts gravity. As the angle of attack increases, the lift generated by the wing significantly intensifies, overcoming the force of drag. As the wing moves through the air, we observe the primary forces at play: lift, drag, and airflow. The P-51 Mustang operates under four fundamental aerodynamic forces: lift, drag, The four forces of flight are thrust, drag, and lift. Lift is fundamentally generated by the wing's airfoil design. As you can see, lift decreases as drag becomes the dominant force. The airflow transitions from laminar to turbulent. Understanding how its wings manipulate airflow is key. The airfoil shape forces air over the top. As the P-51 moves through the air, it encounters resistance, known as drag. Lift, indicated in red, counteracts the weight. Drag, shown in orange, is overcome by the At the heart of the P-51 Mustang's legendary performance lay its engine, a masterpiece of engineering, the Rolls-Royce Merlin. This liquid-cooled V12 power plant was renowned for its reliability and immense power, driving the propeller with unparalleled efficiency.
Crucial to its high-altitude performance was the supercharger, which compressed the thin air, allowing the engine to maintain power where others would falter. Air, compressed by the supercharger, mixed with fuel and ignited in the cylinders, creating the explosive force needed for flight. This relentless sequence transformed raw materials into the force that propelled the P-51 across the skies.
At its core, the Merlin engine is an engineering marvel, designed for raw power and reliability. Its 12 cylinders, arranged in a V configuration, house pistons that tirelessly convert fuel combustion into rotational energy.
Crucial to its high-altitude performance was the supercharger, forcing more air into the engine, counteracting the thin atmosphere. This forced air, precisely mixed with fuel, ignited within each cylinder, unleashing bursts of controlled power. This complete and dynamic system made the Rolls-Royce Merlin engine the legendary heart of the P-51.
Its engineering marvel extended beyond raw power, encompassing remarkable efficiency and reliability, crucial for long-range escort missions.
Every aspect, from its supercharger system to its fuel injection, was optimized for peak performance at high altitudes and speeds. This formidable power translated directly into the P-51's superior speed, exceptional. It was this Rolls-Royce Merlin engine, perfectly integrated, that truly transformed
the definitive heart of the aircraft, the Merlin engine, perfectly integrated into the sleek, aerodynamic fuselage of the P-51 Mustang.
An engine diagram showing optimized power and fluid dynamics. Observe the contained power. Reduced to its core elements, the Mustang engine exemplifies Bauhaus functionalism. Input flows through the device.
Reduced to its essential elements, the P-51 engine block represents pure mechanical force. Its The P-51 Mustang, a masterpiece of functional design, reduced here to its essential elements. As the conceptual model rotates, we see the elegance of its form. The glowing core symbolizes the raw power of the Merlin engine. The P-51 Mustang, a study in minimalist aviation design, emphasizing form and function. The P-51 Mustang utilizes a sophisticated propeller system. As the RPM increases, the blade pitch can be adjusted for optimal thrust. The propeller blades rotate, pulling air inward, creating intake. This air is then forcefully expelled. The P-51 Mustang utilizes powerful thrust to overcome drag, generating significant airflow over the wings for lift. The P-51 Mustang, reduced to its essential Bauhaus elements, demonstrates the principle of thrust. Observe the geometric efficiency. As the propeller rotates, air is deflected, generating thrust. As the propeller accelerates the airflow, we see the resulting thrust, the forward force that propels the aircraft. The P-51 Mustang, a triumph of functional design. Its streamlined form minimized the P-51 Mustang. Its streamlined form, guided by these principles, achieved unparalleled range and speed during its service. The P-51 Mustang utilized variable pitch propellers, adjusting the blade angle, or pitch, as the propeller rotates, air is displaced across the surface, generating the essential forward thrust visualized by this vector. As the propeller accelerates, the individual thrust vectors merge into a single, dominant force, pushing the aircraft forward.
The P-51 Mustang achieves maximum efficiency through its laminar flow wing design. Observe the interaction between the propeller's pressure cone and the turbulent airflow, creating sustained forward thrust. The P-51 Mustang utilized a sophisticated propeller system. By adjusting the blade pitch, optimal thrust is aerodynamic efficiency is key. As thrust propels the aircraft forward, the wings generate the necessary lift. The propulsion relies on three key elements. Engine power drives the propeller rotation, generating the forward thrust. While the propeller provides thrust, the wings are essential for generating lift, keeping the aircraft airborne. The unique curved shape of the wing, called an airfoil, is designed to manipulate the air passing over and under it. This creates a pressure difference, lower pressure above the wing and higher pressure below. This constant generation of lift is what overcomes gravity, allowing the P-51, or any aircraft, to... But wings aren't just about lift. They also contain vital control surfaces that allow the pilot to maneuver the aircraft in 3 dimensions. This section, highlighted here, is the aileron. Ailerons are crucial control surfaces, typically located on the Panning along the fuselage, we arrive at the tail. The horizontal stabilizers contain the elevator, essential for pitch control. As the elevator pivots downward, the airflow pushes the tail down, causing the aircraft to pitch up. The rudder, indicated by the blue outline, modulates the aerodynamic force, directing the aircraft's yaw. Here we see the conceptual model of the P-51 Mustang. The main wing structure, highlighted here, was key to its success. The wings utilize ailerons for control. Movement of these surfaces, indicated by the red arrows. Panning across the main body, we arrive at the tail section. Here we see the horizontal stabilizers and the elevators. As the elevator pivots down, airflow is deflected, causing the nose to rise. Conversely, moving the elevator functional highlights the essential elements of flight. The coordinated turn demonstrates how lift and airflow are managed by the control surfaces. When the elevator deflects upward, it creates a downward aerodynamic force. This causes the aircraft to pitch nose up around its center of gravity. The elevator returns to neutral, leveling the aircraft. Now, watch as the rudder deflects left. The rudder induces a yaw. Once neutralized, the aircraft straightens. Now, watch as the aileron... Here we see the control surfaces. The ailerons induce the roll. The elevator controls the pitch, and the rudder manages the yaw. As the Mustang initiates a climbing turn, the coordinated movement of the control surfaces is key. The elevator Examining the airfoil cross-section reveals how the wing manipulates the air flowing over it. As air accelerates over the curved surface of the wing, pressure drops, indicated here by the streamlines. The streamline design demonstrates aerodynamic principles. The curved airfoil causes air to move faster above than below. Through the coordinated deflection of the ailerons, the aircraft generates a differential lift, resulting in the rolling moment you see here. Inspired by the Bauhaus functional aesthetic, this is the P-51 Mustang. This conceptual schematic highlights the essential structure of the P-51. Note the wing, the cockpit layout centers on the essential controls. The joystick, followed by the rudder pedals, and the functional design of the P-51 cockpit emphasizes clarity. Basic control inputs, such as we move to the cockpit, the functional aesthetic is clear. The instrument panel provides critical data. As the indicators stabilize, we see the functional clarity of the minimalist design. Airspeed and altitude return precisely to their neutral settings.
The cockpit instrumentation stabilizes, indicating readiness for operation.
The control stick manipulates the flight surfaces. Aileron input causes roll, while fore and aft movement adjusts the elevator for pitch. We begin with the joystick, which operates the flight controls. Panning down, we observe the rudder pedals. We begin with the rudder pedals, used for yaw control. Moving to the throttle, pushing it forward increases engine power.
Here we see the primary controls: the throttle, the joystick, and the rudder pedals, rendered in a minimalist style against the white void.
Beyond the physical controls lies the instrument panel, the pilot's primary source of flight information. Here, essential gauges provide real-time data. Altitude, airspeed, and fuel levels are displayed through clean, geometric indicators.
The altimeter, for instance, provides constant feedback on the aircraft's height above sea level, crucial for maintaining flight path.
Similarly, the airspeed indicator informs the pilot of the aircraft's speed, a critical factor for both navigation and tactical maneuvers. Together, these instruments form the backbone of the pilot's situational awareness, allowing precise control and informed decision-making during flight.
The P-51 Mustang, reduced to its essential elements, demonstrates the core principles of aerodynamic design and functional aesthetics.
We move from the primary flight controls to the throttle, which adjusts the power from cutoff to military power. The P-51 Mustang's design prioritized range. By visualizing the internal schematic, the schematic highlights the internal structure, beginning with the main fuselage fuel tank, followed by the auxiliary wing tanks. As we trace the fuselage, the schematic highlights the internal fuel tanks. The animated lines depict the systematic flow of fuel to the engine. The fuel delivery mechanism is a masterpiece of functional design. As the fuel lines converge, the pumps ensure. The fuel system utilizes dual pumps. The selector valve directs the flow, ensuring a steady supply of fuel. This schematic illustrates the continuous fuel delivery system of the P-51 Mustang. Fuel flows from the tanks directly into the engine. Monitoring the fuel flow from the primary wing tank is critical. The gauge indicates a steady depletion rate under standard load. The camera pans across the fuselage, revealing the auxiliary fuel tank. The selector valve then rotates, redirecting. Now, let's explore how the pilot manages this intricate fuel system during flight. Within the cockpit, key controls like the fuel selector valve and fuel gauge allow the pilot to manage fuel distribution. By simply adjusting the selector, the pilot can switch between different fuel tanks, like moving from the main tank to the auxiliary wing tanks. This reroutes the fuel lines, ensuring a continuous supply to the engine from the newly selected source, seamlessly maintaining aircraft operation. This precise management of fuel resources is critical for extended flight duration and operational flexibility. With the fuel system securely managed, the P-51 is primed for optimal performance, a testament to its engineering. This intricate fuel delivery system directly enables the heart of the P-51 to beat, its powerful engine. This synergy ensures optimal thrust and endurance, key to the P-51's legendary operational capabilities. Beyond fuel, numerous interconnected systems ensure the P-51's complex operations, each vital for its mission readiness. Each component, from the retractable landing gear to the intricate flight controls, works in concert to achieve air superiority.
Yet, central to its remarkable performance was an innovative cooling system, ingeniously integrated into its aerodynamic design.
Air was drawn into the fuselage through a distinctive scoop beneath the tail, initiating a highly efficient cooling cycle. This air then flowed through a sophisticated radiator, positioned strategically within the fuselage, where it extracted heat from the engine's coolant.
As hot coolant from the engine circulated through these channels, the incoming cool air absorbed its heat, a critical thermodynamic exchange.
The now heated air was then expelled through adjustable exhaust flaps, a design element that not only This Meredith effect was groundbreaking, transforming a necessary cooling exhaust into a source of additional propulsion, albeit this ingenious design not only effectively This clever thermodynamic integration was a testament to engineering brilliance, maximizing every bit of energy.
Unlike many contemporaries, the P-51 avoided the detrimental drag associated with traditional cooling systems, granting.
Ultimately, the P-51 Mustang's innovative cooling system was not just about temperature regulation. It was a corner. As hot coolant entered the radiator, the system facilitates a rapid heat exchange, expelling the cooled air through the rear vents.
The cooled air from the radiator is repurposed, accelerating through the exhaust flap to generate significant forward momentum. As demonstrated here, the redesigned cooling system operates at optimal efficiency, indicated by the steady.
As the schematic recedes, observe the seamless integration of the fluid dynamics within the cooling apparatus. This innovative system allowed the P-51 to achieve an unprecedented balance. Its clever design yielded extraordinary thermodynamic efficiency. It minimized drag while maximizing the engine's cooling capabilities. This unique harmony allowed for maximized performance without compromise. The P-51 Mustang's cooling system stands as a testament to brilliant engineering. Beyond its impressive performance, the P-51 Mustang was a formidable weapon. Housed within its wings were typically 6.50 caliber M2 Browning machine guns, each fed by extensive ammunition belts. This formidable array allowed for devastating firepower, with each weapon capable of a high rate of fire. Beyond its internal guns, the P-51 Mustang could also be equipped with additional external ordnance.
These hardpoints could carry bombs for ground attack or rockets for concentrated strikes, significantly extending its tactical versatility.
The release of these external stores was controlled by a precise firing mechanism, ensuring accurate deployment at the pilot's command. Bombs were released with precision, allowing ground targets to be engaged effectively. Rockets provided a burst of concentrated firepower for critical moments. But beyond these versatile external options, the P-51's true strength in aerial combat lay within its wings.
Integrated into each wing were several .50 caliber machine guns, fed by extensive ammunition belts, ready for rapid fire.
Each gun features a meticulously engineered firing mechanism, designed for reliability and immense power.
This rapid-fire capability allowed pilots to deliver a devastating hail of bullets, crucial for air-to-air combat and ground strafing.
Beyond its formidable machine guns, the P-51 could be equipped with additional ordnance on optional hardpoints beneath its wings and fuselage. These crucial points allowed for the attachment of various payloads, including bombs for ground attack and rockets for concentrated strikes. This versatile armament allowed the P-51 Mustang to transition from air superiority fighter to a potent ground attack aircraft. With its full complement of weaponry, the Mustang was ready for any challenge, whether in the air or against ground targets. Its payload capability transformed it into an equally fearsome ground attack platform, able to deliver devastating blows with precision.
Rockets added to its versatility, allowing for rapid, destructive attacks against fortified positions or enemy convoys.
Whether engaging in a dogfight or providing close air support, the Mustang's combined armament made it a truly adaptable force. This formidable range of offensive capabilities cemented the P-51 Mustang's legacy as one of his.
The P-51 Mustang's brilliance wasn't just in its formidable offensive capabilities, but equally in its iconic design principles.
An iconic design brought to life. The P-51 Mustang delivered unmatched performance through superior engineering. Its iconic design and unmatched performance ensured strategic impact where it mattered most. The P-51 Mustang remains a symbol of aviation excellence, recognized for its iconic design. The Mustang became a global symbol of aerial supremacy, a testament to unparalleled engineering excellence and tactical foresight. Its design brilliance, characterized by elegant simplicity and formidable power, ensured its dominance in the skies. The Mustang redefined aerial combat, leaving an indelible mark on aviation history and inspiring generations of aircraft design. Its influence extends far beyond its operational years, embodying a timeless synergy of form and function. A lasting legacy, indeed. The P-51 Mustang represents timeless synergy between design and function.
Reduced to its essential elements, the P-51 Mustang embodies the Bauhaus.
Engineered for excellence. The P-51 utilized simple, elegant geometry to achieve mastery of the skies. Engineered for excellence. A legacy of innovation. Engineered for excellence. A legacy of innovation. Icon of air superiority. Engineered for excellence. A legacy of innovation. Icon of air superiority. Forever etched in history. By reducing the Mustang to its core geometric principles, we understand the elegance of its engineering.